Today let's have a short session on electric dipole moment and torque. So let's start. Whenever two equal and opposite charges are separated by a very small distance, then it is said that the system is an electric dipole. Two poles are there. Now one can ask that if the two charges are equal and opposite in nature, so they can attract one another. So how can they be separated? Actually, it is perfectly right. That is, if two charges are equal and opposite in nature, they are attractive and they want always to attract each other. So no distance of separation should be there. So how can this condition be created? Actually, after applying some force electric field externally, these two charges are getting separated and hence the dipole is created. So it is the condition to create a dipole and external electric field should be applied from outside. Now let's learn about the dipole moment. Whenever this charge q is multiplied with the distance d, it gives the value dipole moment and it is a vector quantity. The line joining these two charges to the center of the charges is called the axis of the dipole. Okay. Now we will study about the torque. Whenever two charges are equal and opposite charges are separated by the distance and electrical field externally is applied in them, at that time the positive charge is following the direction of the external electric field, whenever the negative charge is against the direction of the electric field. Suppose if this positive charge and electric field is applied here, here is the positive charge and this is the negative charge here. Now electric field is going from left to right. Then the electric field is also acting on this charge, positive charge q as well as the negative charge minus q. Now the direction of the q after applying the force on it will be along the direction of the electric field, that is it will go from left to right. Whereas this electric field has an impact also in this minus charge and it will move in opposite direction, that is from right to left. Now in this dipole system, after applying this electric field, this positive charge wants to go along the direction of the electric field, whereas the negative charge wants to go opposite to the electric field. So a turning effect is generated, a rotation is generated between the system, that is called torque. And torque is created whenever the dipole moment and the electric field is aligned at some angle. Suppose torque is represented by tau and it is written as Pe sine theta. Actually it's a cross product, P cross E, and we can write this. Okay, I am writing tau. It's also a vector quantity, P cross E. It's a cross product and that can be written as P E sine theta, whereas theta is the angle between dipole and the electric field. At theta equal to 0, that is whenever there is no angle between P and E, at that time the tau is also 0, that is the torque is minimum, and at theta 90 degree tau will be Pe. At that condition the torque will be maximum. That means in the system, dipole system, whenever the angle between the dipole and the electric field is 0, at that time it is maintaining the minimum torque, whereas the P and E are perpendicular to each other. At that time their torque, that is torque of the system, is highest. Hope you have understood. So meet you in the next session.